Hey, I am doing part 2 of lesson 801, and I finished up with standard form. So I wanted to point out a couple things. If you go to page 11 in the 801 lesson, you're going to have 4 practice problems. So stop the video here and practice, or you can go through this first example with me and then do the other 3 on your own. Okay, the first thing we have to do is find the vertex. So remember the formula. It is negative b over 2a. So I'm going to write that formula down, negative b over 2a. Then from there, I'm going to substitute. And I'm going to substitute in b and a. So negative 6 over 2 times 3, which is negative 1. Now, to find the vertex, that just gives me the x-coordinate. I plug in a 1. So 3 times negative 1 squared plus 6 times negative 1 plus 5. Let's simplify that. Negative 1 squared is 1 times 3 is 3 plus negative 6 plus 5. Negative 3 plus 5 is positive 2. That is my output. Therefore, negative 1 is my x-coordinate. 2 is my y-coordinate. So the vertex is at negative 1, positive 2. The axis of symmetry, okay, if I'm graphing it, it goes through the x-coordinate, doesn't it, of the vertex. So it's going to be x equals negative 1. That's my axis of symmetry. And the only other thing I need to find is my y-intercept. If you remember, it's 0, c. Well, c is 5, so my y-intercept is 0, 5. And voila, I'm done. So there's my first example. You guys work through page 11 and try the other ones, and you can check those. Okay, now, I'm going to shift gears. We've done standard form. Now let's talk about the other form. The other form is intercept form. And that's when you have a quadratic already factored. So let's talk about the skeleton, as I call it, the skeleton formula. It is a parentheses x minus r, and I believe they use the notation r1, x minus r2. Now what does the r stand for? The r stands for root. So if you guys remember, roots are where we cross the x-axis. So if I'm looking at a quadratic, and I cross the axis at negative 1 and positive 1, they're my roots. Okay, they're the roots. They're the x-intercepts. We get those from factoring. Okay, so there's the first thing. Now, to find the axis of symmetry from the skeleton formula, it's going to be halfway between these two roots, right? Because it's symmetric. So all we have to do to find the axis of symmetry is take our 2 roots, or the r1 and r2, and find the halfway point. So we add and divide by 2. In other words, we find the midpoint of the 2 roots. So in this case over here, I have a negative 1 and a positive 1 as my 2 roots. So negative 1 plus positive 1 all over 2. 0 over 2, which is 0. So guess what? My axis of symmetry is right here, straight up and down the y-axis. So it would be x equals 2, because remember, the axis of symmetry is a vertical line, and it's always x equal. And that's the line of symmetry. Okay? So that's the overall skeleton formula part of what we're doing. Now let's throw in some numbers. Okay. Okay, first thing. Let's just throw in some numbers. We'll say that we have x plus 5, x minus 3. There is our quadratic in factored form. So what are my roots? And I'm sorry, this is a function. So there's my f of x, so my function notation. My roots are going to be negative 5 and positive 3, right? Those are my roots because I set these equal to 0. So when is x plus 5 equal to 0? When x is negative 5. When is x minus 3 equal to 0? When x is positive 3. So that's why I'm finding the roots. Okay, so as a graph, what does that look like? 1, 2, 3, 4, 5. Negative 5 down here. 1, 2, 3. Now, this quadratic is facing up because A is greater than 0, or A is positive, right? It's a positive 1, so it faces up. So my quadratic will be generally graphed like that. Okay, what's my axis of symmetry? Well, I take my two roots, and I'm finding the halfway point, right? Halfway between negative 5 and positive 3. So negative 5 plus 3 all over 2. Negative 5 plus 3 is negative 2 over 2, which is negative 1. So that means my axis of symmetry will be right here at x equals negative 1. So that's how I write it. My axis of symmetry is x equals negative 1. My roots are 3 and negative 5. Okay, the only other thing I have to do is find my y-intercept. To find my y-intercept, I plug in 0 for x. Okay? So I plug in a 0 here, and I plug in a 0 here. When I plug in a 0, 0 plus 5 times 0 minus 3. This is going to be 5 times negative 3, which equals to negative 15. So that's my y-intercept. So it's going to cross way down here at negative 15. Okay? So 0 was my x-coordinate, negative 15 is my y-coordinate. So to find x-intercepts, you put in 0 for y. In other words, you factor and set equal to y, 0. To find your y-intercept, plug in 0 for x. And you can find your y-intercept. And then, of course, the axis of symmetry is the midpoint between the two roots, because quadratics are symmetrical. So that's how it works. So there you go. There is a quick, down and dirty overview of quadratics in factored form. Now, the LMS is terrific. So if you have any questions about it, go in and watch from page 12 on. And then I'm going to put up the homework, the classwork, so you guys can work on it. It is on page 293. So page 293. The assignment is 1 through 13 odd. And 21 through 26. So, I'm sitting in the room helping you guys. At the end of this video, you can click it off, go into the LMS, check out some of the lessons, or come ask me questions. But I want you to work on your offline lesson, because some of you guys are saying that you're not mastering the material. The way you're going to master it is not by going in and taking that quiz right now. The way you're going to master it is practice. So, go in, work through these problems, come in, ask me questions, make sure you have it before you move on. So, good luck, and I'm here to help you.